is autocorrelation in this context? In the context of time series data, autocorrelation would simply mean periods where higher volatility are in close proximity to other periods of high volatility. In other words, there's volatility clustering. And what drives that is the idea that past values drive present values. So, in other words, if a period had a high volatility, there's a very good likelihood that the period before that also had a high volatility. So, this volatility clustering is the result of autocorrelation, where present values are correlated strongly with past values. So, since the Garch model was supposed to be able to deal with this, a test for this is comparing the autocorrelation of the squared return with the autocorrelation of the squared return divided by the variance. And so the first step would actually be to set up two columns such as this one, and they're already filled out for reasons of simplicity. It's actually going to be easier to explain it this way. So I'm going to highlight the cell here, and as you can see, it's just the square of the return. The square of the return is also present in the column label, and as you can see, it's also present in each of the variance equations associated with the Garch model. So that's basically it. That's how I was able to fill and populate all the cells for the squared return. And I did something similar for the squared return divided by the variance. Since I'd already calculated the squared return for the previous cell, I was then able to divide it by the variance here, as you can see. And then it was just a simple autofill to populate the rest of the cells. Crucially though, the next step is, and as you can see, this is technically, this is actually still for the squared return, so I'm going to fill it as such. So this column is for the squared return, and this column here will be for the, after all that, should be, okay, so it should actually be for the squared return divided by the variance. Okay, after all of that, it still wouldn't take. So there we go. So I've already populated these cells out, and the explanation for this will be much more simple. I've left the first cells blank here, and once I've walked through the process of how these were filled out, the other cells will make sense. So I'm going to calculate the correlation between two arrays. So the first array will actually be from the very first value in this column to the penultimate value, so the second to last value. I'm going to have these as a reference by hitting F4, and the second array will start at the second value and finish at the last value. Again, the last value, like the first, I'm going to hit F4 because I want that to be a reference cell. The significance of this is that I've essentially calculated the correlation between two lagged data sets within the same data set. So by starting at the first data point of this column and then going to the penultimate and then starting at the second and going all the way to the last data point in this column, I've been able to calculate the correlation between a data set and its lag data set. So this in essence is an autocorrelation calculation. And the difference between this cell and all the other cells underneath it is, as you can see, I've altered the lag distance. So whilst here it went from the first column to the penultimate, here it goes from the first column to the pre-penultimate cell. Okay, so it's L91 instead of L92. And I've also started from L6 instead of L5, as you can see here. So in doing so, I'm altering the lags and calculating the correlation between different data sets with a different lag in between each. So I'm going to actually do the same calculation for the squared return divided by variance. So again, I'm going to go and highlight the first value. Okay. I'm going to go from the second value all the way to the last. Okay? And so it's the same process that I followed. And so it's the same process again, and I'm just altering the lags by altering the I guess the non-F4 cells. So the non-stationary cells, in other words. This also needs to be with F4. So and I did the same thing throughout, basically. So the reference cells will always be M4 and M93. Those never change throughout the arrays. What changes are the other cells. In this case, is M89 and M8. The next one is M88, M9. Okay, so in doing so, I'm calculating the autocorrelation between two sets of data with different lags. So they come from the same initial data set, but I've altered the lags between them and then calculated the correlations between the two data sets with two different lags. So now I have autocorrelation values for each of the different lags up to 15 lags. The next step is to sum the autocorrelations. What should happen is the total autocorrelation for the squared return divided by the variance should be less than the autocorrelation for just the squared return. So let's see if that's true. And it is. So it means that the Garch model is actually effective in dealing with autocorrelation in the data set because it's actually almost cut it in half. So the autocorrelation from the squared return is almost double the autocorrelation, or the total autocorrelation from the squared return divided by the variance. So it means that the Garch model was successful at dealing with autocorrelation.